Determine whether the planes are parallel, perpendicular, or neither. If neither, find the angle between them. Our two planes are x plus 4y minus 3z equals 1 and negative 3x plus 6y plus 7z is equal to 0. Well, remember that two planes will be parallel if and only if their normal vectors are parallel. They'll be perpendicular if and only if normal vectors to the planes are perpendicular. And if they are neither parallel nor perpendicular, then the angle between two planes is the angle between two normal vectors to the plane. The acute angle between those normal vectors. So we have a normal vector for the first plane given by the coefficients of x, y, and z. It's going to be 1, 4, and negative 3. We'll call that n1. We have a normal vector to the second plane. We'll call that n2, which is equal to, again, the coefficients of x, y, and z in the equation of that plane in standard form. That's negative 3, 6, and 7. Now the question is, are these normal vectors parallel? Well, we can see, I hope without too much trouble, that n1 does not equal some scalar multiple times n2. Again, for any scalar t. Well, that of course means that n1 is not parallel to n2, and thus that means the planes are not parallel. So again, the planes are parallel if and only if normal vectors, their normal vectors, are parallel. Now let's go ahead and see if they are perpendicular. Well, again, that'll be the case. The planes will be perpendicular if their normal vectors are perpendicular. And normal vectors are perpendicular if and only if the dot product is 0. So we're going to check now perpendicular. After we ruled out parallel, perpendicular, remember, all we had to do was make sure we couldn't find some number I could multiply by n1 to get n2. So maybe I need to explain that a little more. There's no scalar I can multiply or by n2, say, to get n1. If I were going to go from n2 to n1, I'd have to multiply the first component by, what, a negative 1/3. Well, that'll give me a positive 1, but 6 times negative 1/3 does not give me 4, and 7 times negative 1/3 does not give me negative 3. So those were not parallel vectors. Now let's check to see if they are perpendicular. We're basically checking to see if the normal vectors have a dot product of 0. n1 dot n2 is equal to 1, 4, negative 3, dotted with negative 3, 6, 7. That's equal to 1 times a negative 3, that's a negative 3, plus 4 times 6, which is 24. Let's see, this is a negative 3 here, so minus negative 3 times 7, which is 21. Negative 3 and negative 21 is a negative 24, and negative 24 plus 24 is 0. So the normal vectors, and thus the planes themselves, are perpendicular. Again, since the normal vectors had a dot product of 0, that means they are perpendicular, and if the normal vectors are perpendicular, then the planes themselves are perpendicular.